So don't scare her away. She doesn't usually sub for junior high, so I want to let her try junior high, and I think she'll be happy because next door exhausts her. I'm like, oh, these kids are so good.
Sixth grade.
Yeah. Hey, I'm recording. All right, 8.2 quotients. Okay, to recap, last Friday, if the bases are the same and we are multiplying the bases, what do we do to the exponents? Raise your hand. Gabby, you add them. So again, this is a recap of last week. If I have an exponent on the inside and outside, raise your hand. What do I do to the exponents here? Aiden, you multiply them. And don't forget, one of the biggest problems I saw with you guys would be something like this. And y'all would go ahead and apply that 2 to 3 and that 2, but you would forget that it also needs to be applied to this number. And remember, we pretend that there's a 1 there. So then that would be 2 squared, x to the 4th, y to the 6th. But then y'all would say, okay, there's my answer. So y'all would forget to apply it to the main number. That was one issue I saw from a lot of y'all. Then I would see that y'all would forget to work this out. You've got to follow it through. 2 squared is 4. Y'all got to remember that. That is a common mistake that I saw last Friday. So be very, very careful. All right. And again, I have IXLs to help y'all practice this. Okay, so today we're talking about the quotient property of exponents. That's basically when the bases are being divided. For example, x to the a power divided by x to the b power. If the bases are the same and we're dividing, what do we do to the exponents? With?
You subtract them.
That's right. You're going to subtract them. And it is always this exponent always goes first. You can't do b minus a. It has to be a minus b, or what the top exponent minus the bottom one. Always, always, always. That has to come first. You need to always remember to include that minus sign. Even if the b is negative here, then that would be a minus negative b, which would, negative and a negative makes it, adding. There you go. Emily, you pay attention up here? Okay. So remember, when y'all did that, you've got to be careful to follow through and put that on there. All right, let's do some examples. Jump right in. Let's say I have 40 x to the 8th power divided by negative 5 x to the 2nd power. I'm putting a star here. You're going to divide numbers first. Then handle exponents. In other words, don't write over here 40 over -5 and then start doing your exponents. You can do it all together. So for example, 40 divided by -5 is what, Michael? Then we're going to do x 8 minus 2. So we're dividing the numbers first, and then since these bases are the same, we're gonna subtract because it's dividing. So it's gonna be 8 minus 2. Do not do 2 minus 8. You will get a wrong answer. Even if this number down here is larger, let's say it's switched. If it was 2 and 8 right here, you're going to automatically want to do the large one first. No, 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 no. It's always the first one first. So 8 minus 2. And that gives me -8x to the 6th power. Any questions? Any questions? Is it coming back? Hopefully. All right, let's do another one. Taylor, you have a question?
Yeah, is it possible, like, so, if the exponent outside the parentheses is multiplying, is there a way to do it with division? To make it dividing the exponents?
Are you talking about back here?
Yeah, except for division.
No.
No? So there's not like x to, 1 to the power of 3 divided by 1 to the power of 3.
Why would you do that?
I know, but is our book going to do that, and would we need to know how to do that?
Don't think so.
Okay.
Because every time you see with the exponent on the inside and the outside, all you're doing is multiplying. Are you trying to confuse me on a Monday morning?
No.
Okay. All right, let's keep going. What? I can hear you mumbling. Okay. Shh, stop. You're confusing me. 20y to the 6th power divided by 15y to the 3rd power. Okay, in this case, can we divide evenly? Cecilia's saying no way. Therefore, you're going to, here's a star, simplify, or you can say reduce numbers. Because sometimes it's not going to be perfect where you can just go ahead and divide evenly. Sometimes you're going to have to simplify this. So if we divide top and bottom by 5, we get 4 over 3, and then we can handle our variables. That would be y6 minus 3, which would end up 4 over 3 y to the 3rd power. Your y does not go down here with the 3 because it's up at the top. Okay? It's along there. I've had kids, for some reason, put it down here. No, 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 no. It's right up here. Any questions? Do y'all remember this, hopefully? Ooh, y'all are just as tired as I am on Monday. Okay, let's keep going. Can't have a what? Anyone want to guess what you cannot have? What?
Negative exponent?
Mm-hmm. Can't have a negative exponent. Sometimes your book will say, leave everything in, like in the numerator or something like that. Let me tell you something. You need to get rid of those negatives. Those are not good to have. And so we're going to talk about that. And yes, you will see this stuff again, not just in Algebra 2. You will see this in a lot of your high school and even college science classes. So you better remember about this. Or pay attention. So if I have x to the negative n power, raise your hand. Besides the same people that keep raising their hands, if you can remember how to make that positive. Aiden?
You should put it to the bottom.
That's right. We move this to the bottom. There you go. All you do is move it to the bottom. Now, guys, I'm going to show you another example of a common mistake. What if I have this? Michael, how do I make that positive? Huh? Yeah, we move it to the top.
Some people add number. Fine.
Yeah, I mean, that's all you have to do is move it to the top. If you want to put it over 1, that's fine. Because it would still be x to the a power. Any questions? I have links on IXL to help practice with this if you have forgotten all this. Taylor? It's too late for that. All right, let's say I have 2 over x to the negative n power. Emily, I can't have a negative exponent, so what would my answer be? How do I fix that? So then what would my answer be? Okay, so why would I need to move the 2 down? Do I need to move the 2 down? Does it have a negative exponent? So then do I need to move the 2 down? Can it stay right where it's at because there's nothing wrong with it? Yes. So the only thing I need to move up is this, right? Y'all see that? There's nothing wrong with the 2. There's no reason to move it down. So then there's my answer. Notice that. The only reason I'm showing these examples because these are common mistakes of my children. What if I have 3x to the negative 2? Cecilia, how do I fix this problem? Put what over 1? Or, huh? So the x has a negative exponent, right? So it needs to move, but does the 3 have a negative exponent? 3 is above, and then we move this down below. There you go. Do y'all see that? If whatever is not affected can stay right where it's at. You don't have to move it at all. Yes, Aiden?
So if it was like 3 plus 6, would it be like 3 plus 6 over
If it was just 3 plus 6?
well, 3 plus 6 minus the negative 2, right?
Okay, so that's a good one. Do y'all have this down? Okay, hurry.
Oh, I guess I do have that one.
Okay, so let's keep doing some of these so y'all understand it. So you said if it was 3 plus 6 x to the negative 2?
Yeah.
Okay, so he said what if it was 3 plus 6 x to the negative 2? Well, then again, you would leave the numbers and items that are fine, and then just move what you need to. So you would say something like 3 plus 6, and then you could either do over x2. I've also seen it written like this. But really, this would be sufficient.
Yeah.
But still, you would leave the stuff that is not affected on top. This would probably be more appropriate right here. Because if this is affected, I don't know if that would work. This would probably be your answer right there.
Being multiplied by 6.
That's right. So you'd be moving that down below. The 3 still would be considered on top, but anyway. What about if I have this? This is a common mistake. What if I had negative 2x to the negative 2? Yes.
Negative 2 and x
Over
over x.
positive 2. Good. What if I have, oh, this is good. Raise your hand if you want to attempt this one. Taylor?
So that you just move the x negative 2 to the top, making it 1x to the power of 2.
Or just x to the
X
power
to the
2.
power of 2 over negative 2.
There you go. That is a negative whole number. It does not need to go on top because it does not have a negative exponent. I've even had kids, oh, here's another one. What if I have negative 2 to the power of negative 2? Ooh. Anyone want to attempt that? Aiden?
Would it be
1 over negative 2 to the power of 2. Guys, that is another common mistake. If this is attached to that negative 2, you're going to have to make it positive by putting it under 1. Do you know how many times kids will change that negative to a positive? That is a common mistake. So look over all these examples. Make sure you're very careful with what you move and what stays the same, what doesn't move. These are all very common mistakes. I have seen this happen a lot when the negative exponent is attached to a negative number. You guys are great, or kids in general, great about putting it under 1, but then somehow y'all drop this negative sign right here thinking it gets to be positive as well. And this rule only applies to the exponent and whatever the exponent is attached to. Yes, what?
So will we ever change the whole number?
No. Not in this case. All right. Any more questions before we move on? All right, good. Okay, let's get to business here. What if I have 3x to the 5th power y to the 2nd power over 6x y to the 7th power? Okay, I'm going to start calling on people. Michael, you're my first victim.
Oh, you're supposed to divide the two whole numbers first.
Okay, and can they be divided evenly?
No,
So then what do you do?
it becomes 1 over 2.
It becomes 1 over 2 because we are putting it in lowest terms. And then what do I do to the bases and the exponents?
Oh, you subtract them.
Okay, so x is, tell me what? 5. 5 minus 1. If we don't have anything there, we put a 1. And then y is 2 minus 7. So then, what do I get, Michael?
1 over 2. X. 4. -5.
Uh-oh. What do I need to do? I have a negative exponent.
We can put it under the x.
Okay. Because if we have a fraction here already, then we have a numerator and we just put it in the denominator. So it would look like 1 over 2 x to the 4th over y to the 5th. Or you could even say x to the 4th over 2y to the 5th. I have a hole there. You better ask questions if you do not understand what he just did. So this is a negative exponent. All he did was bring it down below to make it positive. The x stays right there on top with the 1. Any questions? All right, Emily, you're next. A to the negative 4 times b to the positive 5 with a negative 2 exponent. So talk me through it. Tell me what to do. Yeah. So what are we doing? Are we? That's right. We're multiplying. Very good. So she's correct. It's on the outside, so we're multiplying it. So then A is what? That's right. It's positive 8. Good job, because negative 2 and negative 4 is 8. And then B is negative 10. Can I have a negative exponent? So what do I do? So what's my answer? You're correct. Huh? Well, look at the one Michael just did. Yes, you're right. Good job. There you go. That is perfect. Good job. And by the way, if you see this negative, don't sit there and say, oh, well, let me put this whole thing under 1 so I can make that positive and stuff like that, because that's not going to work. Solve everything out, and then your final answer you can adjust, just like she did. Okay? Good job, Emily. All right, next victim, Taylor. Any questions so far? All right, so you got a question? 8? Yes, that's an 8. Because -2 times -4 is positive 8. Good question. Do you see it? You have any more questions? All right, good. All right, 34x to the -5, y to the 9, z, they're all being multiplied together, over 2x to the -1, y to the power 3. All right, Taylor, what do I do first?
First you divide, so that becomes 17.
That's right. He divided 34 by 2. It can go in there evenly, so he's done that.
And then that's x 5 plus 1.
It's -5. Let's just work it out totally.
-5. I had
Minus -1. Okay, so look. It's -5 minus -1. Do y'all see that? Y. What?
that's minus 3.
9 minus 3. And then z. And z, there's nothing down here, so it's just z. All right, so Taylor's right. We have a, guys, be real careful with this. That's why I wanted to write that out. Remember, it's always minus, and then this is a -1. Don't, you know what I have kids doing? They say, oh, I need to move this x up here because it's negative. No, 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 no. You solve it first. So I have 2 negatives, and he's right. We're going to add. So then I have 17x, -5 plus 1, and then 9 minus 3 is 6, z. All right, so Taylor, -5 plus 1 is?
-4.
-4, y to the power 6, z. All right, so Taylor, I've got this negative exponent. What do I do?
You put on the bottom, so this would become 17x. Sorry, no, 17y6 times z over x negative x4.
x4. There you go. And he's correct. Good job. Any questions? Yes. Yes, go. Any questions though? Notice this x is the only one with a negative exponent, so he left everything else on top and just put that x down there. Yes.
Could you just put the x under the 17?
I mean, yeah, but it's the same thing. It's the same thing. Because see how all of this was on top and all of this was down below? Does everyone have this? Any questions? Sue, do you want to move up? All right. Got another thing to remind you. What if I have a over b, like a fraction, with an exponent on the outside? This, look up here guys, pay attention. This exponent is going to be applied to the a and the b. If you have a fraction, you apply that exponent to the top and bottom number. So that becomes a to the nth power and b to the nth power. What?
What?
What if the n was a negative?
If it was, okay, so if this was a negative number, okay, let's do one like that. Let's say, that's a good one. A over B to negative n. That's a good one. In fact, I'm going to put a star. Okay, so we're going to apply that to the top number and the bottom number. So therefore, it's a to the negative n over b to the negative n. Can I have negative exponents?
No.
So guess what we do?
Switch.
Switch it. This would be b to the positive n over a to the positive n. We would do a big old switcheroo. So you better have that written down. So good question, Whit. If you have a negative exponent, you apply it to the top number and bottom number, and then you switch it. Yes, Whit?
And if you are going to have a negative on both sides, the numerator and the denominator, are you always going to switch it?
Yeah, because you can't have a negative. But I would do step by step. I wouldn't skip anything. Any questions? Emily, wake up. Look up here. You keep looking at the floor. I'm concerned about you. I don't want you to fall on the floor.
Sitting in the chair.
Okay, but I don't want you to fall. Okay. I know it's Monday. All right, y'all ready? Here's another. Don't fall on the floor.
What?
All right. 2x y to the power of 8 over x to the power of 4 y to the power of 7. Oh, look, Whit. All to the negative 3 exponent.
I don't like this.
Make sure your problems are nice and neat, because that could be an issue. All right, I'm going to show y'all. Y'all be paying attention. You awake over there, Emily? Okay, good. Cecilia, do you need to move up? All right. So we're going to apply that exponent to everything on top, including that 2, and everything underneath. And we're multiplying that exponent with all of these things.
Can we put an imaginary one?
If you want to put an imaginary 1, absolutely.
Makes me feel good.
Okay, you can put an imaginary 1. So then what I get, don't start switching anything yet. I get 2 to the negative 3 exponent. I get x to the negative 3 exponent. Because negative 3 times 1 is negative 3. Negative 3 times 8 is what? Cecilia? Very good. Negative 24. Negative 3 times 4 is negative 12. So x has negative 12. And the y, 7 times negative 3 is negative 21. You cannot see that 21. That's a negative 21. Those of you in the back, that's negative 21. Do you see that, Cecilia? Okay. Now we can start kind of doing some work here. Now remember what I said, don't start moving stuff until you are done. So we're going to start, we have 2 to the negative 3, but we're dividing. So what do we do when we divide and the bases are the same? What do we do to the exponents? Subtract. So I'm going to have x negative 3 minus negative 12. And then y, negative 24 minus negative 21. Y'all with me so far? If you have any questions, ask. All right, so I have 2 to the negative 3. I'm going to move that later. I'm going to combine these first. Because remember I said don't start moving things below until after you're done with everything. These two, a negative and a negative, means you're adding. So I have x to the negative 3 plus 12. And then y, we have the same situation, a negative and a negative. So then I have negative 24 plus 21. Do y'all see where I'm getting all this? So then I still have 2 to the negative 3 because I'm not changing it yet. My x is 9. And my y, negative 24 and 21, is negative 3. All right, now I've combined all that I can. Anything that has a negative exponent can now go to below. So I have one here and here. So my answer would be x to the power 9 over 2 to the power 3 times y to the power 3. Does everyone see that? If you don't, you need to ask questions like, where did you get such and such? But am I done? Emily's shaking her head no. Cecilia, yes. Well, I can't hear you. Okay, look right here. The x has a positive exponent, so I don't need to move it. So it gets to stay on top. The y has a negative exponent, so it's got to go below. Then it would go below too, and there'd just be a 1 up here. Does that help? Good question. So Emily's shaking her head no, we're not done. What do I need to do, Emily? You said I'm not done, so what do I still need to do? Aiden?
You need to do 2 to the power 3.
You need to do 2 to the power.
Thank you, Emily. We need to do 2 to the power 3. We're not done. So, Aiden, what is 2 to the power 3?
8.
Now I'm done. Any questions? I know. Any questions?
That work on Friday was.
Well, get ready.
Oh, that's great.
Everyone got it? Okay. Oh, I got another star. Oh, no. Raise your hand if you can remember. No, I haven't written it down yet.
I thought you were going to ask to do an exam.
What does that mean? Gabby, 1. What does this mean? Raise your hand. Aiden, 1. What does
7, 2, 3.
Michael, what does this mean? Anytime your exponent's a 0, it's always 1. This right here would be 1 over 1. 1 divided by 1 is 1. How about this? What?
What?
Okay, so the bases are the same, and we're dividing, we subtract exponents. So that would be 3 minus 3, right? 3 minus 3 is 0. So x to the 0 is 1. Any questions? Well, just wait. There'll be problems where you're working and it takes up most of the page, and the final answer has a 0 for the exponent, and the answer is 1. I'm serious. You will have that. It's crazy. Does everyone have this? All right, open your book. I don't see y'all doing homework today. So we're going to do all these reviews, and then I'll probably assign the homework tomorrow. See, Cecilia's all happy. So, Cecilia, you ready to do it? You ready to do a problem? All right, open page 336. It is raining. You are correct.
Good job.
You are so intuitive. I can sense when it's about to rain. I can taste it in the air.
All right. I'm so glad y'all can.
It's calling out to you.
Yeah, my strange students. Okay. Oh, y'all make Monday so fun. Okay.
Sounds sarcastic.
I know I'm absolutely being honest.
Emily, don't fall out your chair.
Emily, don't fall out of your chair. All right. Cecilia, you ready? Okay, you awake back there? Okay. 18x to the 7th power. Wait! Over! I haven't finished writing it yet. 2 times x to the 2nd power. Okay, Cecilia. 18 divided by 2 is? The bases are the same, and we're dividing, so what do we do to the exponents? Thank you, Cecilia.
She got the 9 before you went finished.
I know.
Well, she has psychic powers.
She's excited.
Sure, you know what I was gonna.
All right, good job, Cecilia.
7 minus 2.
All right, Gabby. Negative 12, a to the 3rd power times b to the 6th power over 16, a squared b. All right, simplify. So what does that give me?
-3 over 4.
Very good.
Then you're gonna subtract. So it's a 3 minus 2 times b 6 minus 4.
That's all right. And for those of you that freak out, just go ahead and put a 1 there if there's nothing there. Okay, Michaela?
Yeah.
Okay.
I went like this before you said my thing.
So then my answer is negative 3 over 4. I'll let Gabby tell me.
A times b to the 5th power.
There you go.
Oh, because 3 minus 2 would be 1, so it's like nothing.
That's all right. Okay, if you're upset, you can put a 1 here. Another way of even writing this. You can put everything on top and just a 4 on the bottom. It's okay. It is okay. Good job. All right. Any questions so far?
Can I do the next one?
You are going to do the next one. All right, so 5. It is 1 over z to the negative 2.
This looks different.
It's a negative exponent.
Okay, so you're gonna do.
We did several examples.
I know that you're supposed to put it under, but it's already under, so what do you do? I don't laugh.
Yes, the opposite of that.
Look back at your examples. Even Cecilia's over there laughing. That's bad.
I don't see any where they have a.
Start at the beginning. where we said can't have a negative exponent.
I'm looking. Stop, Aiden. You've been mean to me today.
Right here.
Okay, look at the board.
Oh, okay. Oops. Sorry. Hey, well, where'd that paper go? Bring it back.
Now look in your notes. Okay,
Oh,
so
okay, I found one. Okay, so go ahead and bring the Z at the top, and then you're gonna. Wait.
what happens to the exponent?
Do you bring it to the top too, but like as a positive?
Very good.
And then you put a 100?
You don't have to put the 100 because that's the same thing. Okay, so if it's negative, bring it to the top and it becomes positive. Good job. Any questions on that? Michaela's going to redeem herself in number 7. 2x to the negative 3. And that's it. So, what would that be?
Okay, you're gonna do 2 over x3.
Very good. See, there you go. Good job.
Caleb, so sweet.
Okay, so good job leaving the. Okay, stop it. Leaving the 2 alone because it does not have a negative, so it stays on top, and you bring everything else down. Good job. All right, 11. With a to the 4th times a to the 2nd over a to the 5th. A. Tell me what to do.
They're all the same.
Yes, they are. And for those that will cry, there's a 1. Aiden, do you have a question? No, it's Whit's problem. It's not Aiden's problem.
Yeah, Aiden.
Okay, so sit back, look at it, tell me what you would do. Taylor?
What were you having?
All right. So I'm going to give you a hint. If the bases are the same and we're multiplying, what do we do to exponents?
You add them.
So then what would this be?
A to the power of 6. And then divided by a to the power of 6. Oh, wow.
Now what do I do?
Then you subtract. And it'd be 1.
Ew.
There you go. So you can combine when they're on the top or bottom because you're basically multiplying. So this applies last week's stuff. The bases are the same. We're multiplying, so then you add the exponents. You add the exponents, which gave us a to the 6 and a to the 6. Now we're dividing, and the bases are the same, so then we would subtract the exponents. Gave us 0, the answer is 1. All right, 17. Aiden. Okay. We have 16, x to the 6th power, y to the negative 4, divided by 2xy to the 5th power. So the first thing you're going to do is rewrite this on top of one another. So then it's 16 x to the 6, y to the negative 4, divided by 2x y to the 5th power. Okay, so does everyone understand that? This is the problem. You don't want to do it side to side like this. So rewrite it on top of each other like we've been doing. It makes it a lot easier. Now, Aiden, go to work. Tell me what to do.
You would do 16 divided by 2, which is 8. And then 6 minus 1, x power 5. And then negative 4 x y power negative 9.
Okay, so he divided 16 divided by 2, which gave him 8. Then we're focusing on the bases are the same. He's subtracting the exponents, and he said a x to the power of 5 times y to the negative 9. Because negative 4 and negative 5 are negative 9. Now we can't have negatives, so what do? Move it to the bottom. So your final answer is
8x power 5 over 9 power.
there's final answer.
I like this better than stuff on Friday.
Any questions? Cecilia?
Why doesn't the X5 stay on top?
What?
Why doesn't the X5 stay on top?
The x5? Because everything was moved to the top to simplify. Look up here. You gotta look up here when I'm answering. So it's all up here when we subtracted. The x to the power of 5 does not go to the bottom because it's not a negative.
Okay.
Does that help?
It is.
Everyone have this? Okay. 29. Back to you, Michael. X squared times y cubed over y to the power of negative 2. Tell me what to do.
You multiply both top and bottom exponents.
And the y down here, yeah. So then I get x to the power of what? Times y to the power of all over y to the power of. Okay, does everyone understand what he just did? Okay, so now what do?
You would subtract y's.
Very good. Don't start flipping. Don't start flipping yet. The bases of y are the same, so we're going to have x to the negative 4 times y to the negative 6 minus negative 2. He's correct. We're going to subtract the exponents with y first. This is a negative and a negative, so then we're adding. So that would be x to the negative 4 times y to the negative 6 plus 2 now. Okay, so what do I get?
1 over
Wait, x to the negative 4 times y to the... Okay, I have two negatives, so tell me, Michael, how to get rid of them.
you put them both under 1.
So it's going to be 1 over
4x4
and y4. And you're done. Any questions on that? Speak now, forever hold your peace. No questions? Okay. Well, there's not a lot of time to, and so now I'll probably move your quiz to like Monday. Okay?
Wait, can you do it Tuesday? Because Monday energy does.
Mondays.
Taylor? Okay, so I'm going to